All right, today we're going to dig deep, and I mean that literally, into the incredible, unseen world right beneath our feet. We're talking about the massive, hidden structures that hold up, well, pretty much everything, from the tallest skyscrapers to the longest bridges.
You ever find yourself staring up at a massive skyscraper and just wonder? How in the world does all that weight, all that concrete and steel not just sink straight into the ground? Especially if that ground is soft or unstable. It's a great question, and the answer is this amazing piece of engineering that we're about to get into.
Okay, so here's the game plan. We're going to start with the basic problem, how to stop a building from sinking. Then we'll look at the main types of foundations and zoom in on why we need piles in the first place. After that, we'll see how they're actually made, how they work their magic, and even uncover some of their other surprising talents.
Right, so before we can get to the really clever solution, we have to fully understand the problem. And it all starts with the most fundamental part of any structure, its handshake with the earth.
Every single building, no matter how big or small, has a foundation. You can think of it as the single most important connection, the part that takes all the weight of the structure, engineers call this the loads, and spreads it out safely into the ground. If your foundation isn't right, nothing else matters.
So, engineers basically have two main choices. If the ground right at the surface is good and strong, they can use what's called a shallow foundation. This just spreads the weight out over a wide area, kind of like how snowshoes stop you from sinking into deep snow. But what happens when that top layer of soil is weak or mushy or just can't handle the load? Well, then you have to go deep, punching right through that weak stuff to find solid ground way down below.
And that right there is what brings us to the star of our show today, the pile foundation. This is a type of deep foundation, and it is the absolute go-to solution when the ground just isn't playing nice.
So when do engineers bring out the big guns? Well, it's for the toughest jobs, really. When you have a super heavy building on weak soil, piles are the answer. They're also essential in places prone to earthquakes, where the shaking can cause a terrifying thing called liquefaction, where the soil literally starts behaving like a liquid. Piles anchor the building to stable ground way below. High water tables, crazy winds, river currents trying to wash away the soil, these are all problems that pile foundations are built to solve. Okay, so we get it. They're super important. But how on earth do you actually get these enormous columns deep, deep into the ground? Let's take a look at how they're actually built.
It really boils down to two main approaches. The first is driven piles. These are basically ready-made columns of steel or concrete that are just hammered or vibrated into the ground. It's a push-in method. The other way is bored piles, which is more of a pour-in method. You drill a big hole first, then you build the pile right there in the ground.
Let's just zoom in on that board pile process for a second, because it's really incredible. First, a giant corkscrew-like machine called an auger drills a massive hole, sometimes hundreds of feet deep. Then, a huge cage of steel rebar is lowered in to give it tensile strength. And finally, they fill the entire hole with fresh concrete, creating a perfect, custom-built column right there in the earth.
This is all amazing, but it leads us to the biggest question of all. How do these underground columns actually do their job? This is the secret sauce. This is what makes it all possible.
No, seriously, think about it for a second. How do these relatively skinny columns buried deep underground support the crushing, immense weight of a modern skyscraper? It almost seems impossible, right? Well, the answer is that they do it in two really, really clever ways. So, these two mechanisms are called end-bearing and friction. An end-bearing pile is pretty straightforward. It acts like a leg, transferring the building's load all the way down until it rests on something super solid, like bedrock. A friction pile is different. It uses the grip of the soil all along its sides to hold it in place. Okay, let's break down end-bearing. Imagine placing a stool on a thick, fluffy rug that sits on a concrete floor. The legs of the stool punch right through the rug and transfer all the weight directly onto that hard, solid floor. That is exactly what an end-bearing pile does. It ignores all the weak soil and rests its tip, its end, right on a solid layer of rock. It's a very simple principle. If you need to hold up more weight, you just use more piles. But what if that solid rock layer is just way too deep to reach? That's where the genius of a friction pile comes in. Think about this. If you push a ruler deep into a bucket of sand, it's actually pretty hard to pull it out, right? That resistance you feel, that's friction. A friction pile does the same thing, but on a massive scale. It uses the friction along its entire length to grip the surrounding earth, holding the load steady. And if you need more holding power, you just make the pile deeper or wider, or even make the surface rougher to get more grip.
So you'd think holding up billion-pound buildings would be enough, right?
Well, it turns out these piles are pretty multi-talented. They've got a few other tricks up their sleeves.
Believe it or not, piles can actually make weak ground stronger. By driving a whole bunch of them into loose soil, you actually compact and densify it, increasing its strength. They're also not just for vertical forces. You can install a row of them to act like an underground retaining wall, providing sideways or lateral support to hold back soil and prevent collapses, which is crucial during big excavations. They are incredibly versatile.
And that really brings us to the most important point. When you boil it all down, pile foundations are the true unseen heroes of our modern cities. They are the brilliant engineering solution that allows us to build bigger and taller than ever before by finding clever ways to transfer these massive loads safely into the earth when the ground at the surface just isn't up to the task.
So the next time you're walking through a city and you crane your neck back to look up at some impossibly tall skyscraper, I hope you'll think about what you can't see. That hidden engineered forest of massive columns deep underground, silently holding it all up. It's pretty amazing when you think about it.